Welcome everybody in the lecture hall. Welcome everybody on Zoom. Welcome everybody from the future. Today, we are going to start a new course, which is information retrieval, specifically designed for the third year of the bachelor's program. It used to be a master's course. We converted it to a bachelor's course. So as you see, you're free to attend in the lecture hall. So most of you today are in the lecture hall, which is great. If you want to attend on Zoom, we have a few of you on Zoom too. That's fine too. It's also going to be recorded. We will put everything on YouTube. Then you can watch everything with a plus 25% speed, as I hear that this is what is done. So today is going to be a bit special because I'm basically going to give you an introduction, a motivation about the topic in general. And we are actually going to start with the material next week with Boolean retrieval, and then almost every week we will have a different topic. And I will show you the menu at the end of today's lecture. So I'll start in terms of motivation. You know how it feels today. You are having a meal with your friends, and then suddenly you have this question that pops up in the conversation. Can be anything, but for example, you suddenly want to know when Einstein was born. And now we are in the 21st century. So when you start wondering these things, you probably do things differently than what was done in the previous century. So how do you do that? It's an opportunity for me to test the clicker question to get you started. So if you don't already know it, it's by ETH. You can go to this address in your browser, eduapp-app1.ethz.eth, or you can download it to your phone as an app, if you prefer. And then I can show you the question from the other side, right here. I'll give you a bit more time the first time to make sure that you're technically all set up and that it all works. If there are any issues that we can solve, that we cannot solve, we can ask the support in the week. So you can do it from the lecture hall. If you're on Zoom, you can also do it. So this is really for everybody. Does anybody need more time? Did not manage yet to answer? All right, so I'm going to check your answers. So as I expected, the majority of you Googles that on your smartphone or maybe another search engine if you prefer another search engine. Yeah, that's what we do in the 21st century. I'm going to come back to my slides. So normally after every question, if I did it right, I'm supposed to land exactly to where we left. Just need to let Zoom do its thing. Yes, exactly. All right, so we live in great times, right? We can just grab the smartphone from our pocket and then type in there, and then enter this into a search engine, like Google, Bing, Yahoo, DuckDuckGo. And then today, we don't even need to look for a web page because it's even able to directly answer out of the box with at the top of the screen. So it's March 14th, 1879. With a lot of context. So here you have the link to knowledge base, so Wikipedia, for example, a few quotes. Then you have the recommendation system that automatically matches to what other people have been asking. And then at the bottom of that, you are going to get web pages, which used to be what the search engine was actually for in the first place. Who has ever used a search engine like this as a calculator? All right, many of you, right? And indeed, you can do this. But what's incredible is that not just like a calculator, you not only get the answer, you also get the whole calculator downloaded right from the web. You also get some potentially unrelated things, and then the website and so on. So it triggers all kinds of things in the data center, right? So we think of it so much as the natural points at which we seek information that even for calculating, we tend to go there. But we are in 2024. Who actually doesn't use Google anymore and goes to ChatGPT or some AI model now for these things? Some of you, right? Maybe we didn't all slide into that habit. But now we can even directly talk with an AI model and ask the question and even go further and have a bit of a nice conversation with the chatbots, keeps you company a little bit. So what is amazing here is the speed at which everything is evolving, because this is actually not even 2 years old in terms of release. This one, end of 2022. It's a bit more than a year. And I think it's the fastest ever that some product reached out to so many people in just a few days, propagated very, very fast. And now you have AI models all over the place. All of the big companies have their own. Even at ETH, we have one. It's called Ethel, ETHEL. We are actually using it in another course for big data, where we trained the model with a textbook, and the students can actually chat with it. For this course, I don't know yet, because the textbook we are using doesn't belong to us, right? It's in the library, and it was written by 3 professors. I'm trying to see if I get an authorization from them or the publisher, and then we would also be able to use it in the course. I cannot guarantee anything. It's entirely up to them if they would be fine with this, right? And a calculator also works as long as you don't push it. As you probably know, as soon as you start asking for more complex computations, it's just getting it wrong, just because it's never been made for math, right? All it does is compute every time the most probable next words, right? Okay, so this is what we have today. But we did not directly arrive to today with these systems. It's actually thousands of years of evolution that actually brought us here, right? So now we have the search engines that look like this, right? If I go back in time, that was actually the very beginnings of Google. Who was actually born in 1998? I was. Oh, we have others. Okay. So I still remember the very, very beginning, where people were starting to talk about that new engine that originates from Stanford, and then some people started actually using it and typing words. The most striking feature the most striking feature of this page was that it was almost empty. You basically just have a text box, you type, then you click on a button, and that's it. But we already had search engines before Google, believe it or not, right? So these are the 2 founders of Sergey Brin and Larry Page. They were at Stanford, but at the time, I think probably PhD students or master students, I don't know exactly anymore. And some of their professors also got involved, and this is how it all started. Like the typical legend of the Silicon Valley, where you start from nothing and then build a $1 trillion company. This was even an earlier prototype, which at the point had not propagated yet to the whole world. You see, they hired a graphic designer at some point for the logo. So this is how it looked like before Google. The most popular search engine was actually AltaVista. Whoever heard of AltaVista? Okay, so the name is still a bit known. So this is what it looked like. In fact, it wasn't just a search engine. You had a whole portal with the latest news and some catalog of the internet. So it was smaller, the internet back then, the web. And so you had categories of websites, and then you could go in them. In fact, the Yahoo search engine was a catalog. You would search the websites by going into categories and subcategories, right? So this is what we were using pre-Google. What made Google so original is the PageRank algorithm that was able to have a better order of the pages that it would give to you. So the PageRank didn't exist yet. It was a simpler index back then. And there were a few other engines, of course, but this is, I think, the one that was the most popular. Who recognizes the Navigator? Who ever heard of Netscape Navigator? Okay, so that existed back then in the 1990s, and then Internet Explorer took over, and then Google Chrome took over. So you see, this is referred to as the browser wars. So also that has actually evolved a lot. And this is how the web felt in the 1990s. The links where you click were still blue and underlined, and there was also all these GIF animations, which somehow have come back to fashion recently. But back then it was basically full of, the web was full of them. All right. And that's Yahoo. So what I told you about the categories and subcategories, so you could still search, of course, but the documents were organized like this in categories and subcategories. I'll come back to this because that was actually not new to the web. And there was actually something before the internet. So now we have Wikipedia, right? When we search also for an encyclopedia or information. But before people actually were connected to the internet and could search the web, you could actually buy in a shop physically. You could actually buy a CD-ROM that would have an encyclopedia in it, like this. So Microsoft Encarta was one of those you had at the time, and then you would put the CD-ROM in your computer and then load it and access all the knowledge, right? Which at the time was incredible because the amounts that you have in there, if you think of it, that a CD-ROM, it wasn't quite a gigabyte, maybe a few hundred megabytes. But if you think of a few hundred megabytes, that's still hundreds of millions of characters, right? So the amount of knowledge you could store in a CD-ROM was already, for the time, really, really a lot, right? And before computers, because there was an era where we didn't have computers yet, we also had encyclopedias. And there are several of them. There's Encyclopedia Universalis, there's Britannica. It used to be like this, where you have volumes, typically several dozen. So in that case, it's around 30 or so. And so it's sorted, depends how it's sorted. Sometimes it's sorted alphabetically, a bit like the dictionary, except that it's very, very, very large entries in there. And then typically you had a special volume that was some sort of index, where when at school you needed to do some foretrack in front of the classroom, then you would go to the index, look up what you're looking for, and then it would tell you the right volume to go to, right? And of course, an obvious issue with this is that it wouldn't get updates, right? You buy it, you put it in your library. It's actually very, very expensive. And then there's no updates, right? This one actually got updates. You could actually download new versions from the internet. At some point, it turned into some subscription. But here, it didn't update, right? Now, I'm going to get back in time even much, much earlier than this. So you know roughly the times, right? So humans have existed in the current form for millions of years, but the time where things started to accelerate was about 12,000 years ago, right? When we started settling, and then the economy started developing. So this is not as far back in the past as 12,000 years. It's more like 2,000 years in the past. So the Great Library of Alexandria back then was the largest repository of knowledge that you could ever imagine. And in fact, the kings and emperors back then, they were aware that knowledge is extremely important. And this is why a lot of kings actually paid a lot of money to try to have places where you would store the knowledge. So in that case, it was shortly after Alexander the Great, the kingdom got split into three parts. And one of them was Ptolemy the First, and it's with Ptolemy the Second that who is, I think it's his statue right here, that the library was founded. And you could see that the interest for knowledge was so enormous that they had this obsession of collecting all the papyrus, and there was no books back then, so papyruses may be the poor form that they could find. And in fact, there was an order that whenever there was a ship that was in the harbor, they would just search the ship for books, not books, sorry, just a habit, papyruses, bring them all, or scrolls, bring them all to the library, copy them, because you had to copy them by hand back then, and then bring back the copies to the ship and keep the originals. They always wanted the originals because with copies, you can make mistakes. So with the original, there's less risk of a mistake, right? So, so there was this obsession to gather as much as possible, as much knowledge as possible. In fact, the library wasn't just shelves with scrolls and papyruses on them. In fact, it already looked like a mini university. You had a living room, a dining room where people could eat together. You had free food that already was invented thousands of years ago. If you do a PhD later, you'll know what free food is. And this attracted a lot of scholars and researchers who go there. It wasn't that many, actually, more like 20 or 30 people. And then they would do research and read and read and read and write new papyruses or scrolls. Right, so that was thousands of years ago. There's a legend that it actually was burnt down, but in fact, it's more like very slow, that it was let go very slowly, like less funding and so on. So after a while, it started losing in importance. Okay, so that's what I can say about the Great Library of Alexandria. There's other examples. I'm not going to say so many details. The Vatican Library has a lot of objects. In fact, there's the word codices here. Codices is the plural form of codex, and a codex is actually a book. It's this idea that you take the sheets of paper and bind them together into a book. So that was the ancient form of the books that we had back then. All right, and there are many other examples of libraries in the world. So bibliothèque, by the way, bibliothèque, that word actually popped up already in the Library of Alexandria. You already had the Greek form of bibliotheca. My Greek is not very good, but basically the root of bibliothèque was already originated from that time. And I think that synod was also from there, means community, synod, and that's also from that time. Anyway, so this is in Germany, the Herzog August Bibliothek. So the number of books is not today, it's back then in 1661, it's just a few snapshots over time. The British Museum had in 1845, 240,000 books. Now they were called books. The Library of Congress in the United States in Washington, D.C. In 1990 had 100 million documents. So that serves as the basis for all the parliaments, but it's actually, you can consider it as a national library. The Shanghai Library, in fact, is not only the second largest, it's the second tallest. There are 24 floors in there, 24 floors of books, of shelves of books. It's the second tallest. Do you know where the tallest library is? It's Indonesia, Jakarta. That's the tallest library in the world. And the largest in size, in the number of books, is the British Library. All right. Now, if I come back to this idea that in the Yahoo search engine, you have these categories and these subcategories of websites, this actually predates the internet. In fact, the idea that when you have a very large number of books, you need to organize them in a way that people can easily find them without computers back then. So you need a classification. And the one that is used, I think it's still used today, but I knew it when I was at school, in primary school, I still remember that. There is a classification of the subjects based on numbers like this. Who has already seen that kind of numbers in a library? The 3 digits, many of you, right? So this is called the Dewey Decimal System. And the idea is that you have categories. So the first digit is the very broad category, like history, geography, and so on. Then you have a second digit that subdivides it, then a third one, and then you have dots, periods, and it continues, right? So it's used throughout the world and very, very popular. And in fact, these numbers that you see here, they are even on the books. You have every book has the number in there, maybe together with more letters that index it, right? Who knows indices from the database, relational database lecture? right? Database management. All right, so this is the same idea, but as you can see, you don't need computers to build indices. It was done already with books in libraries, right? So this is what it looks like. You see all the large categories. It's all standardized, I think even worldwide, and you have all the list here. Okay. Another name, and I think in German, that's called Verschlagwortung, this idea of indexing the subjects and grouping the books or the library items in this way. All right, so there's a whole community of people who deal with this. Now, of course, today we have computers, but in the very early days of computers where we didn't have transistors yet, so it was more like mechanical machines, there was somebody called Vannevar Bush who had the idea of some sort of automated system that would allow you to look up information and bring in. So this is a desk. You basically sit at your desk, and you have these screens and all this machinery that brings to you the information. So it feels strange to look at this today because basically having screens on a desk is not really something that surprises us anymore. The only thing that might surprise us is that we see a lot of machinery that is more like mechanical engineering here, even though today, as we know, it's more done with electronics and electrotechnic. But for the time, it was actually visionary, right? So this is Vannevar Bush. There is a quote by him that I will also show you that was incredibly visionary as well on the growth of information. I have another question for you on your backgrounds. Even though I kind of know where the majority will lie, but I know that it's not 100%. So what is your main background? So of course, I expect a lot of computer scientists, right? So the bachelors in computer science, but sometimes we have visitors from other departments, like mathematicians, I know from time to time. Seems like 100% today, really 100%. Okay, so you're all computer scientists. Very good. So I can safely assume all of this, all of the prerequisites that you have. Okay, so that settles it. Okay. Again, we should land back to exactly where we were. Okay. I have a few more people who joined us on Zoom. Okay. So I give you a short history of information like libraries and books and so on, but what about databases? It's actually one that I do at the beginning of every one of my database lecture. And yes, I said database lecture because information retrieval is a database lecture. At least I think it is a database lecture. But you will understand why during the semester. So here's a short history of databases and data. So what I call database prehistory is typically everything that's before 1970, roughly. So back then, that's even older than the Great Library of Alexandria. How did we transmit information? By speaking and by singing, right? So it was just repeated and repeated from generation to generation. So of course you had the information within families, but you also had the information about all the rulers and the kings and so on, who had people specifically hired for that kind of things. They would even sing. And then this is how it would propagate from generation to generation. But as you can imagine, the problem with that is that it gets distorted and you can introduce mistakes. You also forget information. So in fact, it's very, very difficult for us today to access all of this information that was transmitted already back then. If you want to push it, you could even argue that there was already data that is 4 billion years old, which is the DNA that we are all made of, right? You could consider it data, but that wasn't in our control. The speaking thinking is in our control. And then there was a revolution, which was writing. Writing solved the problem that information gets lost. And in fact, we can see directly today with archaeology, because everything that is written like this, we can read it, decipher it, and actually we have it exactly as it was back then, no distortion, right? But the challenge is to translate it, because not only do we need to figure out the alphabet that is used in there, we also need to figure out what it means. And in fact, a lot of them are still not deciphered as of today. However, AI is again here to help, because with AI, we somehow manage to decipher many more of these and counting. So it's very good at finding the relationships between the symbols and all the information in there. So this tablet here, which seems a very heavy tablet, but still a tablet, has text, it's lines, right? So it's actually telling a story, probably about some king or emperor or queen or of the time. It's the Rosetta Stone, actually. Who knows the Rosetta Stone? This one is probably the most famous of them all, right? It contained the same information in several languages, and this is how Egyptian hieroglyphs were finally translated. But not all of these tablets are actually made of lines of text. There is a second kind of tablets that looks more like this. And every time I look at this tablet, I just feel strange, because it feels like I'm in some sort of science fiction movie where somebody went back to the past and left an artifact of today there, because that looks almost like some sort of iPad, so a tablet in the modern sense, with some spreadsheet software running on it. And in fact, what that shows is that our ancestors back then, that's thousands of years old, they already knew the concept of a table, a relational table. And they already stored data. This is a relational database, right? The word database doesn't imply a computer or anything. It's a database system that implies the processing. But this was a relational database. It contained Pythagoras triples, so the three integer sides of a right triangle, that were known at the time, and that was very useful for geometry. Was used, for example, to figure out who owns what lands even after there is a flooding. Right, so this is, I just love that. This is incredible that this is thousands of years old and people already knew tables. In fact, even if you do polls today and ask people, the one thing that people understand the most, like in a newspaper or infographics, is tables. More than pie charts, more than scatter plots, more than anything, it's the tables that people understand the most. All right. Then there was something else. It was the invention of printing. Printing solved the problem of duplicating information. Before printing, whenever you had a book or a scroll or a papyrus, you needed to manually copy it. And there were people who are spending their entire days actually copying codices or papyruses. But with printing, all you need to do is assemble the letters of what you want to duplicate many times, and that's it. In fact, the fact in German, it's called Buchstaben. So the Buchstaben is literally this right here, right? And you know the uppercase, lowercase, in English, we say uppercase, lowercase, where that comes from is because the Buchstaben that correspond to uppercase were in the upper part of the case, and the ones with the lowercase letters, they were in the lower part of the case, right? So this is what revolutions the propagation of information and creating millions of copies of the same information. And it culminated in the 19th century with the golden age of the press, with all the newspapers that could easily disseminate information. So that's printing. So Gutenberg is usually the name we associate with printing. And only later came computers. Originally not necessarily transistors and electronics, as I told you, it used to be mechanical, but it used to be like this. It would fill up an entire room in a university or in some research facility. And whenever you switch it on, the city switches off. So suddenly the people run out of electricity. So that's saying how much it actually was consuming at the time. And on top of that, not only did it consume as much power as the entire city, but the power of it is orders of magnitude less than the smartphones you have in your hands. So this is how fast that actually all evolves. So on these computers right here, and the more modern ones, all the way until the 1960s, you would put your data, your information, in some directories and files, right? So I assume you all know what directories and files are. I'm saying that because now with the smartphones, there are no more directories and files, right? This is some sort of abstraction that the general public maybe is becoming less aware of. On desktop computers or laptops, though, it's still exposed to the user. But basically, this is how in the 60s people stored their information. And then in order to query their data, they would write programs. It was not in Python back then, but in some programming language, and they would manually go through the files and analyze the information and do what they want with that. But that was actually a problem because that was very expensive in resources to write all of these lines of code. And I'm saying that on purpose with a parallel of today with people writing Python. It's kind of the same thing as history repeating itself. And that was solved in 1970. That's the start of database history by Edgar Cott, who suggested that we should actually shield the user from the details of the implementation and the physical storage of the data. The user shouldn't ever worry about anything else than a table, for example, so with rows and columns. And now if you think of the clay tablets having a relational table that is thousands of years old, that is very intuitive to the user. So this is what the user should see. That's how the user should interact with the data. And all of the rest should be hidden. The files, the directories, the actual codes, what would be Python today, that should all be hidden from the view. This is called data independence, the principle. So it's at the fundamental in relational database systems, but also in big data. Then in the 1980s, this is when we started having C++. Then in the 90s, Java, so object-oriented programming. So people started also to connect that with relational databases. Then we had in the 2000s the NoSQL era, not only SQL, where we had key value stores, white column stores, graph databases, triple source, document stores, and so on. So that's all covered in big data. But basically, it's the scale, that's the massive amounts of data that came out of this. The reason I'm showing that to you is that even though that's not the big data course, I'm still showing you that because we will still scale what we do in information retrieval, like to manage to index text or information that can be larger than a computer and also require a data center. So this is why I consider it also a database lecture and why this is actually relevant. So just a few basics of big data so that you're up to date. So volume, variety, velocity, the 3 Vs. You need to know these prefixes, including the last two that were more recently invented. So I assume you all know maybe the first 6. There is a trick, if you know a bit of Greek, is that the prefixes were on purpose chosen to resemble the corresponding Greek number. For example, tetra, penta, hexa, hepta, and so on. So it's on purpose. Nonna, ronna. That's on purpose. And the Greek number that this corresponds to gives you the number of groups of 3 zeros. Like tetra, for example, has 4 groups of 3 zeros, so that's 12 zeros. All right? So that you should really know by heart, all of these prefixes. This is international, this is all standardized. So that's volume. Then we have variety. Variety means that even though originally in 1970 it's the table that was the queen of everything, we also have other shapes that then emerged or came back to the front. We have trees, we have graphs, we have cubes, and most importantly, we have unstructured data, text, and so on. And in fact, in this course, we are going to focus on this unstructured data. But the techniques that we will use are actually not completely unrelated to the database techniques that you would have with the other shapes. And you probably will notice a few a few analogies with relational database systems that you're already familiar with when we deal with text, right? So there is this whole spectrum of how structured the data is, starting with unstructured data, which is just, for example, text. And then it becomes more and more and more structured. So you start having like the graphs and the trees. We'll see in big data that these are actually denormalized tables when we drop the normal forms. And then the cubes, which are the most structured that you can have. So the focus for us is unstructured data. So unstructured data is something that at first wasn't very present, because back then in the 70s, we really focused on the information that we can store in tables. But there was an explosion more recently, because we keep storing and storing and storing a lot of data, and now unstructured data is all over the place. The problem is that we don't know how to do this with the typical relational database systems that we have. So it needs completely new ways of dealing with it. So it can be text, it can be pictures, right? So what you see here, I think, is the first photography ever when it was discovered. So it was a bit of a landscape. So that was done with this what we call a negative, probably, which was some sort of flat. I don't know how to call this thing, but flat object, and then you project the light on it, and it's storing the snapshots of the landscape. Yeah. So it's funny, right? When you compare this with your smartphones that have this super high resolution enhanced with artificial intelligence, and that was actually the first time that we see something that people actually saw exactly in the same way back then. All right, there's not just text, actually, it's also audio, for example, sounds. We can also have, for example, text, but written in like microblogging, for example, tweets, even though it's no longer called that way, probably. Then we have the videos, sequences of bitmaps, images, and so on. So it used to be like this was terra incognita, like we kind of don't really know what to do with them. But now, if you look at everything that's been happening in the past couple of years with the evolution of generative AI, now this is actually something that is pretty well covered with technology. You probably saw recently this new 1 minute generative AI video that came out of OpenAI. I think it's called Sora. So this is now something that we also master technologically. Maybe there's still a lot to discover. It's a very, very beginning, but this is happening. So now the difference between unstructured data and structured data has to do with the fact that unstructured data is in a very raw form, not processed, just pixels or characters and so on. There is no explicit structure, like in a relational tables, you have rows, you have columns. But if the data is unstructured, then everything is implicit, right? Feature here is also meant the same as in the machine learning sense of feature, right? You basically need to infer them and figure out what feature you want to use as your input, right? Characters, grammar, pixels, waves. And if you think of deep learning, it can even be anything that we don't even understand, right? That just shows up in the neural network. Right. Now there is, that's kind of a problem with the implicit structures, is that there is something that we call the semantic gap. Is that if you open a book today and you read it, it's effortless, right? Why? But that's because you know English and you have some background and you know the vocabulary. But there is a gap because if you do the same thing with a scroll that was written thousands of years ago, then you don't know anymore. And the problem is that if you don't have the context information about the encoding or the way that this is written, there's nothing you can do, right? And so there is a gap between the representation of information, so the ones and the zeros or the signs that you see on your tablet, and the actual semantic description of the information that actually makes it understandable and meaningful to whoever reads that. And in fact, this is what we need to feed into the computer to deal with it. There is very often the concept of data, information, knowledge, and even wisdom is the fourth one as layers of abstraction for data. So data in itself is really just raw, it's ones and zeros. If it has meaning and you can interpret it, then that becomes information. If you turn it into a meaningful application, that's knowledge. And then wisdom is where you have even the distance and experience that enhance your use of it. All right, so that's variety. And finally, volume, the last one, the last V. Volume has to do with the bytes, actually, the amount of data we have. So the web is an indicator of the scale that it reads, because before you had the books in the libraries, and the web was the first time that you can actually access information that is not located where you are. You can just connect somewhere, anywhere in the world, and the information is sent to you. This was invented actually in Switzerland in 1989, 1990 by Sir Tim Berners-Lee at CERN. What is funny is that when he invented this, so it was basically building of existing technologies like hypertext and so on, but it was rejected in conferences and so on, like, oh no, there's nothing interesting in there. And then he ended up in a corner of a conference room with a poster, which is kind of, as a PhD student, you submit a paper, it's rejected, and they say, okay, no, you can still have a poster. And the web actually ended up as a poster in a conference. And now you know what it has become. Like the Tim Berners-Lee is world famous now. But this is a nice story, right? And on the web, precisely, a lot of things I'm going to show you are there. You have repositories of knowledge. For example, for finance, you have Bloomberg that is established. For research, you have archive.org with all the papers. You have repositories for shops, of things that you can sell. I could also have put Digitech Galaxus in there, all the Swiss online shops. You have the social media with repositories of pictures, and so on, and so on, and so on. Now, why have things become different today compared to even 20 years ago when we already had the database system? So what made it challenging? Well, it has to do with capacity, throughput, and latency, and how they actually evolved in time. So I'm going to quickly give you a high-level abstraction of what has happened. For this, I'm going to use specific definitions for this. People can use these words in different ways. What I'm going to call capacity here is how much data you can store, like the capacity of a hard drive, 1 terabyte, for example. So that's the capacity. The throughput is how fast you can read it. For example, a couple of 100 megabytes per second, or megabits or megabytes per second to transmit the data, right? So all the bytes that are flowing over the wire. And then the latency is when you need to wait to receive the data, right? It's not instant, so you need to wait a bit. Some people use latency as a measure until the end of receiving the data. Here, I mean it until the beginning of receiving the data. So just be aware that there can be these two interpretations. So when do I start receiving data? Now, if we go back in time to 1956, that was the first commercially available hard drive, IBM Ramac 350. 5 megabytes. It could store 5 megabytes. That's absolutely incredible. What's incredible is also that this is how big it is, like 1 meter, 70, even 1 meter 50. So this is absolutely gigantic. It could read an amazing 12.5 thousand characters per second, bytes. And the latency was 600 milliseconds before you start receiving, or the seek time, before you start receiving something. Why the latency? Because this is actually rotating. All of these hard drives, they have a rotating part. And when you read, you have some sort of reading head somewhere. And you need to wait until it rotates all the way that the bytes you want to read are below the head. So this is where this actually comes from, the latency, that there is, you need to wait for a while until you can read. And then if the bytes are contiguous, like next to each other, then reading is just rotating the disk and reading off the ones and zeros. Now, how have it evolved? until today? Well, this is what we have today. It's actually much smaller, but I think this is the largest that I could find as of 2024. It's the DCHC 670 of Western Digital, 26 terabytes that fit in there, 250 megabytes per second. The latency is 4 milliseconds, and the dimension is like this, right? You will know how large a hard drive is. And I'm not even talking about SSDs, because the SSDs, it's even better than that. But we still use HDDs a lot, hard drives in data center, because they are cheap compared to flash drives. We are almost at the break. But what I want to show you as a motivation for the break, and that's the question after the break. This is how between 1956 and today, so these two hard drives that I showed you, the gigantic one and the small one, the capacity increased by that much. The throughput and latency, I'm not going to click and make them appear. They're already here. This is by how much the throughput increased, and this is by how much the latency decreased, right? So if I normalize per unit of volume, so what fits in a cubic centimeter, for example, the improvement is actually 20, I even have to think like 20 trillion, 20,000 times for the throughput and 150 times for the latency, right? These are rough numbers because every time I recalculate with the new numbers every year, it kind of fluctuates around that. So you don't need the exact values, of course, just the orders of magnitudes that this is immensely more than this, which itself is more than this. And so the words with which I'm going to end before the break is we are in big trouble. We are really in big trouble because now this is how much data we have and this is how fast we can actually read it. So a lot of the big data evolution and also 1 week of this semester will be spent on how do we solve that problem of this discrepancy between the capacity, throughput, and latency. So I'll see you in 15 minutes. I was a bit 2 minutes late, so I will let you until 17 past 11 for the break. I'm giving you back the 15 minutes, and then we'll finish the introduction. Thank you very much.